Alright, just so you know, chapter 10.2 is a 2-day lesson. The reason is because I think you need some time to let this stuff actually settle into your head. So spend today trying to at least get the grasp on what's going on, and then tomorrow hopefully you kind of get a hold of everything you need to. Again, this does represent the major foundation of chapter's material. We're going to be expected to simplify radicals without the aid of a calculator, simplifying it for us. There are two ways that I will introduce. You are going to be responsible for being able to answer questions on both methods on your homework. Not really deeply, but again, you just need to stick with one. So whatever it is, you need to pick one of the two methods for simplifying simplifying radicals, and after that, you should be good. The key to simplifying prime factors, method one, is to understand what the root's key value is. So if you look at the following roots, you have the third root of 32. In this case, the key value is 3. If you were asked to simplify the radical of the fifth root of 96, the key value here would be 5. The tricky part about square roots is that the invisible number is there, but if you don't remember, it is actually a 2 because there's an invisible 2 there. We'll only be working with square roots for this chapter for Algebra 1, but you will eventually be able to do higher level radicals later. Again, so just keep that in mind. So once you understand what the key value is, that's the first part. Next thing you got to do is understand what prime numbers are. Prime numbers are numbers that can only be divided by itself in 1. Here's a list of those numbers: 2, 3, 5, 7, 11, 13, 13, 17, 19, 23, 29, 31, 37. Notice that there's only one even number, because 4, 6, 8, 10, 12 can all be divided by 2. So again, 3 is by itself, 5 is by itself, and so on. Also notice that 1 is not prime also. So by definition, 1 is not a prime number. So again, prime numbers, look at those numbers, make sure you understand what they are, make sure you understand what they represent, because in the end you have to be able to break these numbers down to prime factors. So the first step, again, using this method is learning how to break them down to prime factors. So let's look at this problem real fast. Because 2 is the first prime factor number, or prime number, what we want to do is 2600 divided by 2 and see what we get, which is 1300. So it's 2 times 1300. Then you notice that 2 goes into it, so divide that by 2 and you get 650. And then you take that, and again, there's another 2 in there I can see because it's even, and that is 2 times 325. Now, of course, 2 is no longer in that number, so now you move on to 3. Now, an easy trick for 3, and you need to probably write this down for yourself, you add the digits, and if the digits add up to something divisible by 3, then you can divide by 3. 3 plus 2 is 5, 5 plus 5 is 10, 3 does not go in. 5 is next, but we see that it should have a 5 because it ends in 5, so 325 divided by 5 is 65, so that's 5 times 65. Of course, 65 can be divided by 5, and it goes to 5 times 13. Now, if you look at 13, you recognize that 13 is one of those weird numbers, which means your prime factorization is 2, 2, 2, 5, 5, 13. And if you take your calculator and you type those numbers in, 2 times 2 times 2 times 5 times 5 times 13, you notice that your answer is 2600. In other words, 2600 is made up of this unique set of prime numbers. Every number has a unique prime factorization, so that's what you just did. You broke it down to its own particular prime factorization. It's almost like this number's DNA, and that's what you want to be able to do at some point if you're going to use this method. 1020. Again, 1020 is even, so obviously 2 goes into it. It'll be 510. 510 is also even, so obviously 2 goes in. I think that'll be, I don't know, 265, 255, I don't know. 255. And once again, looking at this, you can't bring out 2 because it's not even, but before you move on to 5, make sure you add the digits. 5, 6, 7, 12. 12 is actually divisible by 3, which means that 3 probably goes into this number, and it does. 3 times 85. 5 plus 8 is 13, which means 3 does not go in, which means all your 5s are gone. Now what you want to do is check the 5, because obviously it ends in 5, and you get 17. And again, 17 is just a weird number. I don't think anything goes in, so our prime factorization for 1020 is 2, 2, 3, 5, 17. Again, if you were to type those numbers in, 2, 2, 3, 5, 17, then you end up with the actual number of 1020, which is what we want to have. Once you understand the key value and you have found the prime factors, the rest is very basic. The key value represents how many duplicates or how many sets it takes to remove a value from the root. Pretty much what I like to do is I like to imagine the square root as a gate, and the only way, or a jail, or some sort of containment. And the only way you can get out of that containment is if you have a certain number of duplicates. And so talking about this, what we're going to do first is break down 360, which is 2 times 180. 2 times 90, I would do as much of this in your head as you could. 2 times 45. 45 is actually 3 times 15. 15 is 3 times 5. And so what you have is the square root of 2, 2, 2, 3, 3, 5. So again, this is what's on the inside. If you broke this down to its DNA, as we like to say, the prime factorization, this is what's in there. Now what we're going to do here is we're going to pull out pairs, because remember that the key number for this is 2. So we see 2 2's here. No pairs there, but we also see a set of 2 3's. So what we bring out, and this is again what you'll be expected to do on the computer, is you'll pull out a set of 2's, you'll pull out a set of 3's, and what didn't come out is a 2 and a 5. Again, 2 came out, 3 came out, a set of 2's came out, a set of 3's came out, but the 2 and the 5, who did not have a pair, stayed on the inside. In the end, 2 times 3 is 6, 2 times 5 is 10. That is your simplified radical. And here is how you answer it in your calculator to kind of check it. Do the square root is 360. Notice what you get. Then type in 6 square root 10. And notice that you get the same exact set of numbers, which means that those two things are equal. This is usually how I like to check my multiple choice questions whenever I have the option. If I don't know how to do it, but they have all the answers, I like to take that, plug it in until I get the answer that actually matches. That way I know it actually works because it has the same exact value as what it's supposed to have. 1134. 2 times, I don't know, 5. Ooh, that's a tough one. 1134 divided by 2 is 567. I know 2 doesn't go in it, but adding 6, 11, 18, 3 does go into 18, so I think 567 can be divided by 3, and it can. That's 3 times 189. 9, 18 again, so 189 divided by 3 is 63. 3 obviously goes into 63 21 times, which is 3 times 7. So again, once you get down to all prime numbers, put them back into the root. 2, 3, 1, 2, 3, 4 3's, and then 7 is also in there. And again, now what we are looking for with this key number being 2 is sets of 2 numbers that come out. 2 has nothing to combine with, but you do have a set of 2 3's here. You also have a set of 2 3's here. 7 has nothing to combine with, so what comes out is a 3 here, a 3 there, and then 2 and 7 have to stay on the inside. In the end, 3 times 3 is 9, 2 times 7 is 14. That is our simplified radical. And again, if you want to check that, do the square root of 1134, and then do the square, or 9 root 14. Sorry, you didn't get to see the first one. And you notice again you have the same set of numbers there, which is what we're looking for. Alright. I recommend, especially if you're taking a quiz, that you always do that, because the only way you miss that question on a quiz is if you actually don't check to make sure you did everything right. There are small mistakes that you can make, and it is smart to at least type that in after you did it, just to make sure. This method also works helps us to understand how to simplify variable portions of radicals. For example, square root of y to the 33rd. You could put 33y's in there, or you could use your head and remember that your key number is 2. And what you could do is just say, how many times is 33 or 2 going to 33? So since 33 divided by 2 is 16.5, that means 16 pairs, and this means 1 left. And so what that tells me, because it's 16.5, is that it's going to be 16 y's that come out. And again, because it's 0.5, obviously 1 y is left over, and that's all you have to do. Now you do want to make sure your number doesn't mix in with the root like mine did here, because otherwise it looks like the 16th root of y. But y to the 16th times y is what you would end up with, because again, pairs are of 2. 33 of these are in here. That means 16 of those would be able to come out. and 1 of course would stay. E to the 50th, again, if you're looking at variables, this is 50 e's in there, and you know you're pulling them out in pairs of 2, so what you do in your brain is 50 divided by 2 is 25, and what that means is that you have 25 pairs, and since there's no 0.5, it means 0 left, because they all come out in sets of 2, so this would just be e to the 25th. Again, you only leave the root if something is left on the inside. So that is how you do it using prime factorization. Method number 2 is perfect squares. So if you're not a fan of finding prime factors and you have just one last shot at simplifying radicals, now you do have to use it for variables, but in terms of numbers, there is another option for you. But this does require for you to memorize a set of perfect squares. And I'll tell you right now that the prime factorization method will even work with these numbers that I showed you. I don't know where I showed it to you. Oh, the numbers that I showed you right here. Because what you would do is you would break down your 32 and you would pull out sets of 3. So for example, if on the inside you had 2, 2, 2, 3, 3, you would pull out a set of 3 2's. The 3's would have to stay, and you would simplify it. So again, I would recommend that you use the prime factorization for the overall picture. But again, in terms of this test, just make sure you find something that works. And again, your other part is just to pretty much memorize a set of perfect squares. 4, 9, 25, 49, 121. Again, if you don't want to do the prime factorization, then you must have these 5 numbers in your head memorized and known. And every time you do it, you have to think about those 5 numbers, because those 5 numbers will typically break down most of what you're looking at. These perfect squares represent the squares of the first prime numbers. If you look back at that list, 2 times 2 is 4, 3 times 3 is 9, 5 times 5 is 25, 7 times 7 is 49, 11 times 11 is 121. If 121 doesn't work, you can try 169, 2, I think 89, whatever that might be. But if those don't work, you might want to go further than that. But typically for what you're going to be doing in Algebra 1, these 5 numbers will suffice. So again, your job is to pull out as many as you can. So what you want to do, if you're going to use this method, is you pull out as many 4's as you can pull out. Then you take as many 9's as you can take out. Then you take out as many 25's as you can take out. If there's still more, then you try it at the 49's. And if that doesn't work, you try the 121's. But typically it doesn't go that far, because typically by the time you pull out a couple 4's and 9's, everything's pretty much gone. So let's go back to the ones that we did earlier just to make sure you understand. So again, I'm going to look at 360, and the first thing I'm going to do using this method is divide by 4 and recognize it's 4 times 90. And then I'm going to go 90 divided by 4, which I don't think does. So 4's are all gone. Now I try 9, because remember it's 4, 9. So 90 divided by 9 is 10, so that is 9 times 10. And what you're looking at here is that 4 is a perfect square, 9 is a perfect square. And so I circle my perfect squares. And what that tells me is, remember, this is underneath the root. So you have the square root of 4, you have the square root of 9. Well, the square root of 4 comes out as a 2. The square root of 9 comes out as a 3. And then, of course, this 10 had nothing to go with. And so you end up with 2 times 3 root 10. 2 times 3 turns into 6 root 10. And if you look back at the example from before, you'll find that that works exactly the way it's supposed to. It is important that you understand you are square rooting, because these are still under the radical. So yes, you have a 4, yes, you have a 9, but what you're doing instead of pulling out a 2 times 2 is you're bringing a perfect number out and you're square rooting that number and bringing out the real version of it. So the square root of 4 comes out as a 2, the square root of 9 comes out as a 3, the 10 had nothing to go with it because there's no 4, no 9 in there, and 25 is too big, so you can stop. 1134, again, what you want to do first is check your 4, so 1134 divided by 4, nope. 1134 divided by 9, yep, 9 times 126. Once you know 4 doesn't work, there are no more 9s, so let's do 126 divided by 9. Yep, that's 14. And again, checking your list. 4 is gone, 9 doesn't work for 14. 25, which is your next number, is bigger than 14, which means that's all that comes out. So what we're looking at here is, remember, you're doing the square root of both of these. That comes out as a 3. This comes out as a 3, and this 14 stays, which again simplifies to be 9 root 14. Again, I'll tell you this method does not work with variables, but again, at least it does give you something else to deal with numbers, so that's the key thing. The essential question pretty much asks, what is the best method to use in simplifying radicals? Really, again, there's only one method for working with variables. but just best to choose whatever method works best for you. So if you like the prime factorization method, which again I'd recommend that one, but again, if prime factorization just isn't clicking for you right now, but you can do it using the perfect squares, then go with it. Because remember, we're getting ready for a quiz this week. We're getting ready for a test in a couple weeks or a few weeks. So whatever gets you to the end part is the best thing. At some point, you'll have to learn the prime factorization. But again, in terms of this test, I don't recommend the best way, because even all those can be adjusted to whatever's going on. So just use your work today to try to both methods and make your call from there. Now there are again some questions on your homework that you'll see that I haven't gotten to, so let's go ahead and look at those and then go from there. You will see numbers that have an outside and inside number, and that's okay. It'll say simplify it. So what's your job to always do? Your job is always to look at this and try to figure out if 98 can be broken down. And again, I'm going to use the perfect square this time just to see. So again, you can use any method you want, but what you honestly do is you ignore that 6 and just work with the square root of 98. So 98 divided by 4 does not work. 98 divided by 9 does not work. So 4, 9, the next one's 25. 98 divided by 25 obviously does not work. 98 divided by 49, and look at that, 49 times 2. And so what you can do now, because obviously 2 doesn't come out with anything, is you remember that 49 comes out as a 7. But here's what you have to remember when there's a number on the outside. That number is going to stay there. 49 comes out as a 7, and there is your root 2. Alright. This turns into 42 root 2. And again, to check that, you just simply type both things in. 6 root 98 equals, and then 42 root 2 equals, and you notice that you get the same answer. Alright. I'll use the other way on the square, or the 144 t to the 7th. Again, what you want to do is you want to separate it into parts. 144 is 2 times 72, which is 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. Those are all your prime factors. So what you end up with is 1, 2, 3, 4 2's, 2 3's, and then t to the 7th. Again, that t to the 7th did not go away, but we do not think about it when we're doing prime factorization. Now looking at our pairs, you notice that these two is a pair, or those two represent a pair of 2's. Here's another pair of 2's, and here's a pair of 3's. And there's no other numbers left, which means that you're pulling out a 2, you're pulling out a 2, you're pulling out a 3, which of course gives you a number on the outside. And what you want to kind of get used to, what you could do is just work out the numbers in one part, work out the variable on the other, which I'm not going to do that here. But what you can do is you can now take this t to the 7th and say, yep, t to the 7th is different because I'm supposed to divide by 2. 7 divided by 2 is 3.5, which to us means that 3 t's come out and 1 t stays. So 3 t's come out and 1 t stays. And now you need to break this down. 2 times 2 is 4. 4 times 3 is 12. T to the 3rd root t. That's it. And again, if you want to check it, do the square root of 144, and notice that your answer is 12, which is exactly what we have. So the number is treated differently than the variable, but you just have to make sure you know how to do both. And the last thing I want to do real quick as we wrap this up, I know it's a long video, but again, you have 2 days to work on this, is look at these here. The rule you have to understand about fractions is that that fraction can be separated to square root of 36 over square root of 49. Obviously square root of 36 is 6, square root of 49 is 7, and there we go. The beauty of your calculator is that you can do the square root of 36 over 49 equals, and because we do have the math enter, you notice that you still get your 6/7. The problem is if this wasn't something that would turn into a nice fraction, you wouldn't see it and you'd have to go the other way. But again, right now for what you're looking at, you could just type it into your calculator, check it out, and see what happens. Other than that, I might not be in your class right now because I think I'm gone for the morning. Just do as much as you can, and if necessary, go on back to some other homework and practice, or get ready for chapter 9, make up, whatever you need to do. Just make sure you stay busy and find something to do for the day. Also, the first few questions on this, if I'm not in the room, might be a little frustrating, but once you skip past that, I think you get into other stuff you can actually do. So Don't just stare at it or say you can't do it. Just try it out. Work with some people around you, and let's get this thing done. Other than that, go ahead and go to your Math Excel. Good luck.